you. Today I wanted to go through a bit some of the history of the Ethereum project and where we started back in 2013 and 2014, and some of the changes that we've that the project has gone through since then, and how we think about some issues in a way that's different from how we thought about them 5 years ago or 10 years ago. So who here remembers the Ethereum white paper? This was, who here has read the Ethereum white paper? Any part of it? This is a document that we published back in 2014 that basically describes some of the initial vision that we had for the project, right? And in the white paper, we described some of the basic ideas behind Ethereum. Basically, that Ethereum is this decentralized system similar to Bitcoin. It's a blockchain, except the big difference is that unlike most of the previous systems that existed before, which only try to support one application, Ethereum has a built-in programming language which allows users to build their own applications so that and then you can write your own application as a piece of code. Then you upload that code onto the blockchain, and then that application runs that code, and that piece of code is your application, right? So you're not just using one application. You are there. It is okay. So you're not just using the blockchain is not just supporting one application. The blockchain basically lets anyone create their own applications that then it's okay. That then get added on top. Sorry, it's confusing. Right, so anyone can write their own applications and upload them, and these applications can talk to each other. Anyone can use those applications, and they're all part of the Ethereum ecosystem. So at the beginning of this white paper, I talked about some of the ideas that other people have had, some of the ideas that I have been starting to have. So colored coins is one of the early protocols on top of Bitcoin for issuing your own assets. So today on Ethereum we have ERC20, but back then we had colored coins, and colored coins was this early attempt at making a protocol for issuing your own assets on top of Bitcoin. Actually, what's interesting is that very recently there is a very limited and very specific version of colored coins called ordinals that is on top of the Bitcoin protocol. So actually, something like colored coins on Bitcoin is having a bit of a comeback, right? But colored coins is only one application. You can have tokens that represent access to physical objects. That was called smart property back then. You can have other kinds of assets, so like domain names are a good example, right? So you can basically have a system on the blockchain for registering websites, registering usernames, keeping track of names that users and applications use, and you can do this in a decentralized way by doing it all on chain. The concept of smart contracts, this idea that you can have computer programs that live on the blockchain, and those computer programs can directly control digital assets, right? So an asset does not need to be owned by a person. An asset can be owned by a program. And this concept of smart contracts can be used to implement many kinds of more complicated applications. So for example, you can have prediction markets, you can have financial gadgets, things like stable coins, leverage, all of the different things that DeFi offers. Then there's this concept of decentralized autonomous organizations, which is basically using a smart contract to implement the voting logic or governance logic of an entire organization on chain, right? So instead of dispute resolution for an organization, needing to be done by a legal system, you can have this very low-cost way of just doing that directly on-chain. So a lot of the like concepts in terms of applications have basically been like here since the beginning, and a lot of these concepts have basically stuck like even until this day, right? So a lot of these concepts have we have these things today, right? We still have, back then we had colored coins. Today we have ERC20 tokens. Back then we had smart property. Smart property actually has not really seen that much progress, but like we do have on-chain ticketing now. Namecoin, we have ENS, and lots of people use ENS, right? So like my own blog actually is uploaded to and is accessible through ENS, right? So if you use an Ethereum-enabled browser, like I believe if you use Brave, you can do this. You can type in vitalik.eth, and you just get like the front page of my blog, right? So it's something that you can use, and it works. Smart contracts and DAOs. There are many kinds of DAOs worldwide that use many different kinds of logic. So there, so far, this hasn't really seen huge adoption outside of like projects within the DeFi ecosystem, but they exist, and many of them have been operating pretty well for years. So that's like some of the applications that we've seen, right? Now, there have obviously been other applications that have come in that have just completely surprised me. So NFTs are a good example. I did not predict CryptoKitties. I did not predict the monkeys. I did not predict NFTs. But a lot of the other things that exist today are basically very similar ideas to what we had 10 years ago. So research on proof of stake, right? So today, Ethereum finally is a proof of stake chain, right? And proof of stake has greatly increased Ethereum's security. It has reduced Ethereum's energy consumption by more than 99.9%. So before what was called the merge, the full switch to proof of stake of Ethereum last year, Ethereum consumed about, I think, as much electricity as like I believe it was like 40% of Singapore, and now that's reduced to like basically zero. So it's proof of stake transition is finally complete, but this is a thing that we have been working on in the ecosystem for the last 10 years, right? So the first 5 years of proof of stake development were basically research, right? Basically us trying to understand what proof of stake is, what all of the different options are in the proof of stake space, before finally converging on like the particular version that actually works, right? So this is a picture from a blog post from 2015 where I would basically describe a mechanism called consensus by bet, which attempts to essentially have validators send a series of messages expressing higher and higher levels of confidence in a particular block in order to try to agree on a block much more quickly than you can in proof of work. So it turned out that consensus by bet had a lot of flaws, and it was needlessly complicated, and it was actually much worse than kind of much simpler protocols that ended up turning into Casper FFG. But it was a step along the road to us understanding the space better. Now, actually, for anyone interested, I made a Twitter thread back in 2018, and if you want to see it, just scan that QR code. And basically, in that Twitter thread, I go through the journey of like Ethereum's proof of stake research, and basically how we went from first starting to explore and being okay with maybe switching to proof of stake at some point in the future, until we finally decided on the exact algorithm. So first 5 years was research, then like next 4 years after that was development. Scalability, right? So scalability is this super important thing for Ethereum, right? Because as of today, the Ethereum blockchain only supports somewhere between 10 and 20 transactions per second. And between 10 and 50, actually, depending on like how complex and how large those transactions are. Now, This is a very small level of scalability, right? If you want to support mainstream finance, mainstream payments, and systems at a global scale, you need to have something closer to 100,000 transactions per second, right? If we only have 20 transactions per second, the world population is 8 billion, so it would take 400 million seconds, which is about 13 years for people to be able to do something on chain even once, right? And so increasing scalability is just a very big deal. Now, the very early effort in improving scalability was called sharding, right? And what we're doing still is a form of sharding, right? But a lot of different things have been designed and changed to this mechanism since then. So the idea of sharding basically is this. A simple blockchain, like Bitcoin, has limited scalability because it requires every single computer on the network to process every transaction. So let's change the design. Instead of every node processing every transaction, every node only processes a small portion of transactions, right? It's like how BitTorrent works, for example, right? BitTorrent lets people share many terabytes of data, but BitTorrent does not require literally every person to store every file, right? Because that would just be way too much data for people. And so the challenge is how do you do some kind of BitTorrent-like scaling, but still have it be a consensus system so that people are agreeing on what order things are coming in so that you can build things like finance on top of that. This was a hard technical challenge. This is one of our earlier ideas. This is 3-level sharding, where you basically split up nodes into groups, have individual groups vote on individual things that happen. It's a very complicated construction, and one of the things that we've been forced to do since then is just try really hard to reduce the complexity, right? Basically, try hard to really make things very simple, because we just know that something that takes 2 weeks to write down a spec takes 2 years to develop. And so if it takes 6 weeks to write down a spec, it would take 6 years to develop. And so we had to really push the complexity down, make a lot of sacrifices to push the complexity down, and we ended up coming closer to the structure that we have today. One of the interesting things about just Ethereum's technical progress is how similar the things that we talk about today are to the things that we talked about 6 years ago. This was a slide from a blockchain conference. I forget exactly where. I believe in Taipei, where I basically talked about what some of the important problems in Ethereum are. And the 4 I mentioned are pretty simple, right? Privacy, consent to safety, smart contract safety, and scalability. And if you listen to me or anyone else talk about what are Ethereum's biggest problems today, you get basically the same answer, right? Privacy, consent to safety, smart contract safety, and scalability. So the challenges are the same as the challenges were 6 years ago. But at the same time, what is I think is interesting is some of the progress that has been made since 2017, right? So 2018, the beacon chain, right? This is when we work on Ethereum's proof of stake really switched from research to development. And this is where we had this big workshop in Taipei, and then we later had another workshop in Berlin. We really came together, we agreed on approximately what would be the design of Ethereum proof of stake, and we switched to actually working on building it. So this is an early diagram describing what the beacon chain, proof of stake and sharding would look like. This is actually not what it looks like today, right? What it looks like today is even simpler than this, right? So we've been continuing to push complexity down more and more as much as we could. But this is what it looked like in 2018. Now, in 2023, the status quo of Ethereum from a usage perspective, right, is basically that in many places, there's few people who are using crypto, and people who are using it to do things like trading digital monkeys. In many other countries, very many people are using it, but a lot of the time they're using centralized exchanges, right? There are many countries around the world where, for example, there's more than 10% of the population holds cryptocurrency, right? Like you hear statistics like this from places like, Argentina, Turkey, Nigeria, Ukraine, like many countries that have different kinds of complicated political or currency situations. And in those places, like being able to have this alternative means of transacting and holding savings is just a lifesaver for people, right? And it's valuable for people already. But the challenge is that when you look at like how these people actually use the cryptocurrencies, they're always going through centralized exchanges. And centralized exchanges can be good and they can be convenient, but as we found out last year, centralized exchanges often break. So one of the ways that I see the challenge is basically in trying to find get to the point where we can actually have more people using, not just cryptocurrency, but like actually using the blockchain and like actually benefiting from, like the openness and the kind of global permissionless and decentralized nature of the technology. So problems are the same as today, but there has also been a lot of progress, right? So if we look at privacy, for example, in 2017, privacy was just a technical challenge, right? Basically, there's this new type of cryptography called ZK snarks, right? And also called zero-knowledge proofs. And what this lets you do is it basically lets you create a cryptographic proof that proves certain, like any mathematical property, like anything that can be computed on data that you have without revealing anything else about that data, right? And this was used first by Zcash. Zcash is a privacy-preserving cryptocurrency that launched in 2016, and Zcash used ZK snarks in order to achieve privacy, right? How do you do this? Basically, when you spend a coin in Zcash, instead of pointing to directly which coin it is that you're spending, you make a proof that proves that you are spending a coin that you have that has not yet been spent without revealing anything else about that coin, right? So you're proving exactly the statements that you need to prove to have a currency system that does not hyperinflate, but everything else is being kept private. And back in 2017, the challenge was just importing the ability to use that technology onto Ethereum. ZK snarks rely on a very complicated piece of math called elliptic curve pairings. And in the Byzantium hard fork, we basically added some what are called precompiles, that basically a kind of opcode that let you use pairings, verify pairings inside of Ethereum. And so using smart contracts, you could actually build an application on top of Ethereum that has the same kind of privacy-preserving logic. That was 2017. In 2023, the status quo technologically is very advanced, right? There are very advanced ZK snark libraries, development environments, tools, protocols. We have Plonk, Halo 2, Plonky 2, like the StarkNet Air, Cairo, just like this big long list of like really fun and fascinating technologies. But privacy actually hit a different kind of bottleneck, which is like basically like legal issues and issues around like coins coming out of these systems getting accepted by the wider ecosystem, right? So there have been legal issues around Tornado Cash, which is basically, you can think of it as a clone of Zcash that sits on top of Ethereum. Like basically just because like hackers ended up using it a lot. And as a result of this, there has been work coming out on a concept called proof of innocence, which is basically, what proof of innocence lets you do is it lets you prove that your coins that came through a privacy system also did not come from one of the hackers, right? So you're proving that you're not one of the hackers without without completely revealing where your coins came from. And actually, there's like a paper coming out about this idea soon. There's already several implementations from Chainway and some other companies. So like basically there's a lot of this like work in the details on like trying to modify these privacy systems to increase the chance that like if you actually use one of these privacy systems and then you go and deposit those coins in an exchange, then the exchange like actually will accept those coins and will not like get maximally suspicious of you. Also, ZK Stark verification, making it cheaper, right? It costs about 400,000 gas to verify a proof. We want to make verifying proofs cheaper. Part of that is layer 2s, part of that is aggregation protocols. So the difference between 2017 and 2023 is that in 2017, we were just trying to like make the basic building blocks work, right? In 2023, the building blocks work, but the focus is on optimizing those building blocks and on like doing a bunch of this more complicated work on trying to like make it fit in together with the mainstream world. Consensus safety. In 2017, we were basically just finishing the research part of the proof of stake development process, and we were just starting development. In 2023, Ethereum has fully switched over to proof of stake. We've become a fully proof of stake system, but the challenges have to do with reducing the complexity of the protocol, improving the security of the protocol, addressing centralization concerns, making it easier for people to stake, making a concept called PBS that makes it, again, easier to stake because you don't have to run complicated algorithms to optimize how much revenue you make. Smart contract safety. I feel like smart contract safety has kind of maybe advanced the least out of all four of these, right? Because in 2017, we were only 1 year after the DAO hack, right? Who remembers the DAO hack here? Good. It's basically, one of the very first big DAOs. This was a smart contracts that controlled about $150 million and used it as and was intended to be an investment fund. It got hacked. And basically the hacker actually tried to get away with quite a lot of money, but then actually Ethereum ended up forking to basically return the money to the DAO's original owners. And so that was the only time anything like that happened in Ethereum. And so back in 2017, this memory was like still fresh in everyone's minds, and everyone was like very worried about this kind of security. And so people were like working, hard on improving the security of the programming language, making contracts safer, making everything safer. And in 2023, like a lot of that work has succeeded, and I think the amount of hacking happening has quietly reduced. And when it hasn't reduced, it's because people try to build things that are 20 times more complicated, right? If you're building something today which is not 20 times more complicated than what people were building in 2016, you're generally actually quite safe, right? There have been lots of systems that have survived for years without being hacked, and I think that's a very impressive accomplishment. There's other kinds of safety that have been improved. So in a few months after the DAO fork, there was something called the Shanghai DOS attacks, where basically an attacker took advantage of a lot of bugs within the Ethereum protocol itself that made it possible to send transactions that basically slowed the entire chain down. And we just worked for months, basically releasing an update every day, and the hacker kept finding a new bug every day, basically fighting against and finding all of these bugs. And eventually, after 4 years, there were a series of different changes and improvements. Then EIP 2929, also a lot of improvements to the Geth code base. Right, the Geth developers have done some really amazing work. And at the end of this, a lot of those security problems have basically actually kind of quietly been solved, right? The thing with security that's a little bit annoying is when you switch from proof of work to proof of stake, there is one big event, right? The merge. The event happens, and you can have parties in Berlin to celebrate. When you succeed in security, there is no event, because the whole point is that there is no event, right? But it's sometimes important to remember that the events not happening is good news, right? So I think there have been real improvements there, but there are still a lot of ongoing problems. Scalability. So back in 2017, sharding was just an idea. We were also talking a lot about state channels and plasma. These were these big layer 2 solutions. And then now, after that, around 2020, everyone switched over to rollups. And so today there's all of these different rollups. There's ZK EVMs, there's optimistic rollups, there's non-EVM rollups. These rollups are like actually starting to kind of take off their training wheels and become properly decentralized. Arbitrum made a major step toward that this year. Polygon made a major step toward that this year. There was ongoing work on decentralizing these systems further, hardening the proof systems, making them more secure, making the proof systems faster, so that with a ZK EVM, instead of proving one block in 5 hours, you could prove a block in 20 minutes, and then maybe in the future it'll go down to 2 minutes, maybe eventually 12 seconds. So a lot of progress, right? And like the areas are still the same, but there's just huge amounts of gains that are being made on each one. Lots of other things too. So Virtual trees. 5 or 6 years ago, stateless clients were just an idea. Now Virtual trees are like a 10-person team that's written thousands of lines of code, that's thought deeply about how to actually push this out onto Ethereum. It's like maybe 1 to 2 years away from actual implementation. Improvements to the EVM, EVM max, EVM simplification. Account abstraction. Account abstraction is like this really big one, right? Like everyone who supports account abstraction has a different reason why they support account abstraction. And I think the reason why is because account abstraction is like inherently this extremely flexible thing, right? The goal of account abstraction is to basically say, instead of having accounts that are controlled by a key, you have accounts that are controlled by a computer program. If you have an account that's controlled by a computer program, users can have different kinds of logic for how those transactions get approved, right? So instead of having one key, you can have 3 different keys. You can have 5 different keys where like some of them are controlled by other people. You can do multi-factor authentication. You can have keys that are stored in trusted hardware modules that exist on like any modern phone. And you can have more secure ways to authenticate to that. You can use hardware wallets, and you can combine multiple hardware wallets together, right? You just get a lot of these different options. You could even do like really things like potentially use an email account as a way to authenticate yourself as a way to authenticate yourself into an Ethereum address, right? And like using an email account to access an Ethereum account, it feels kind of pointless because it feels kind of like centralized, right? Like what's the point? But on the other hand, like for new users, an email account is something that they already have. And for experienced users, you can do multi-factor authentication, and email can be like one of the things out of 3 or 4 that secure your wallet. So a lot of progress being made in a lot of different ways, right? Now, getting back to reality and users, right? One of the events that I always talk about was this trip to Argentina that I made back in 2021, where I was really impressed by just how many people did things were like actually using cryptocurrency, right? I remember on Christmas Day, I was just walking outside, and on Christmas Day, most things are closed, and so I just wanted to go and find a coffee shop. The first coffee shop that I found, the owner recognized me. He had told me that he had a crypto wallet, and I asked if we could pay with ETH, and he said yes. And we ended up paying. Actually, I even used Arbitrum to pay, so even on a layer 2. So being very modern. But there was a problem, right? He was not using the blockchain. He was using a Binance account, right? And I appreciate the things that Binance has done in just making cryptocurrency accessible to people, where if they did not have Binance, they would not have had any other option, right? And I think it's good to have those alternatives. But at the same time, I think as an ecosystem, the goal is to try to move to having less and less central points of failure over time, right? And I think even Binance agrees with this, right? They've been getting more and more into kind of more, partially decentralized things over time as well. And actually, yeah, it's interesting. A lot of these other, centralized exchange CEOs, when I talk to them and I tell them, like, I'm not even the one that has to tell them I think centralized exchanges suck. They're the ones that tell me, like, hey, we actually want to be more decentralized, right? And, for me, I'm scared of them having, like $1 billion that they can steal. From their point of view, they're terrified that they have $1 billion of other people's money that they can lose, right? So improving decentralization here, I think, is like really a victory for everyone, right? But the problem is that decentralized ways for people like this to hold their coins just do not exist yet, right? And like trying to really improve and make things better for people on chain is like one of the really big challenges, right? So basically, like, can we make it viable for people in these positions to like really actually use the chain, benefit from like the openness and decentralization of a global permission blockchain, and can we get to a world where, like, in all of these areas of applications that like really people have been thinking about all the way since 2013, we get to a version that like actually provides benefits and also actually works for people. So the technical work, the whole time has been following a pretty consistent direction, which I think is fascinating. I think the tools have changed, right? The tools have changed a lot. 10 years ago, we were not even thinking about ZK snarks. Now we are. But the goals are the same. Now I think there's a lot more of a need to focus on like actual use and adoption. And the solutions involve technical work, but they're more distributed and they're more on different layers of the stack, right? So what this means is that like the Ethereum Foundation and the Ethereum core development teams and the client teams are not like the only place to do extremely important stuff, right? Like wallet companies are also a place to do extremely important stuff. Application developers are a place to do extremely important stuff. I mean, even like building enterprise blockchain systems, like this is a thing that people have tried to do for many years, but I think if you build it as a Validium, like a layer 3 on top of Ethereum, then like there actually is a way to make that viable and to make that like actually work for people who are like basically actually provide like the benefits of decentralization, but at the same time make it like actually possible for people to deploy things, right? So I think those are like some of the biggest changes that we've seen in Ethereum over the last 10 years, right? Basically just a long, slow journey from Ethereum being an idea to just like having to actually deal with like 10 to 50 different challenges of getting this stuff like actually usable in the world. And I hope over the next 5 years we're going to like end up actually solving most of these challenges. So thank you.
Now is the thanks Vitalik for his sharing, and I hope the students learn enough how to drive a new technology and move to really influential usage. Now we have about like less than half an hour as usual for Q&A. Vitalik may want to stand here so you can have access to the mic. Mm-hmm. Any questions from? Okay, that red shirt. You.
Hello, my question is actually how do you look at the Ethereum staking? Because currently more and more Ethereum are staked into the mainnet. And since you think not many liquid Ethereum still around on the blockchain. So do you think this is good for the development of Ethereum ecosystem? Because if we observe this phenomenon in other traditional finance, in the money market, when sometimes this money or the value coin they stop circulating within the blockchain, it could cause some issues for the ecosystems. So what do you think?
Yeah. I actually don't think that it's like a big deal if like even 80 or 90% of the ETH ends up getting staked. I think it's because like ETH is not a currency in the same way that a dollar is a currency, for example, right? And so like it's an asset that has different kinds of properties. And I expect that over time we'll find more and more ways to simultaneously use ETH both for staking and as collateral in other kinds of applications. Figuring out how to do that well is a challenge, but I think it is something that we will move closer and closer to. I mean, I think finding ways to continue making sure that staking stays decentralized, even as Ethereum staking ends up, being something that almost every Ethereum user does is, or at least a very large portion of Ethereum users do, is definitely a challenge. But it's, it is one that lots of people are really working on now.
Thank you. I actually have a second a question. Sorry about that. It's really about things you communicate more with in the US and sometimes in the Europe. You have exchange ideas with the different Western capital. So do you think from their perspective, will they in the future promote other chains development such as Arbitrum or Optimism or even other layer ones to compete with Ethereum? So what do you think on that point?
I mean, sorry, I feel like I don't understand the question well. Like when you say Western, like what kinds of actors are you talking about?
It's more like the Western VCs. For say you have the Coinbase Ventures.
Yeah, I mean, I feel like VCs have been like sort of pushing everything almost since the beginning, right? Like there's, like back in 2018, there was EOS, and then back in, 2014 and 15, there was BitShares and all of these systems. So I feel like, yeah, like Western capital has been like trying to get into like every layer one pretty much since the beginning of like the idea that you could make new layer ones. So I don't really expect changes in that regard. I definitely think that there's limits to how much they can accomplish, right? Because like as we've seen, like they've tried this kind of like shock and awe playbook of coordinating and throwing huge amounts of money toward a particular ecosystem and like trying to be a kingmaker. And I feel like we've realized that like that's actually much less effective in crypto than it is in other places, right? Like I think for an ecosystem to really succeed, it needs to have a strong community, and that's not something that capital actors are really capable of creating. Like they just don't have as much experience in that. So I think the layer twos and also, the other layer ones that will succeed are more likely to be the ones that like do a good job on that angle. And yeah, like making a community is good is hard, and it's not something that can be replicated.
Oh, thank you. Because on social media, just a few days ago.
Give chance to other audience
okay,
as
okay.
well.
Thanks. Sorry about that.
Yeah.
So, this lady. Okay. Yeah.
Hi.
Здравствуйте. 你好. Hello, Vitalik. I am Thea from Fervent Blockchain. And my question is that after the widespread adoption of ETH, especially after post, maybe in the future, how we may deal with significant wealth inequality problem?
Sorry,
Okay.
how do I deal with which problem?
The significant wealth inequality problem in ETH.
I see.
Thank you.
Yeah, I mean, I think there's like an aspect of the problem that we can deal with, and an aspect that we can't, right? The aspect that we can't is basically that like these are open ecosystems, and anyone from the world can kind of come into them. And so inequality that exists outside of Ethereum is just inevitably going to become part of the inequality in Ethereum. And it's like difficult to change the protocol in a way that affects wealth distributions, right? Like the decisions that we've already made, for example, right, is if you look at the current ETH supply, the ETH supply comes from like basically 3 different sources, right? Like there was the original pre-mine that was given to like the foundation and core developers, which was 10%. Then there was the sale, which is 50%, and then there's the amount that was mined, which is another 40%, right? And so there are like 3 different kinds of people over the course of like 7 years that had an opportunity to like become part of the initial ETH distribution, right? And like that did work better for us than like, for example, what a lot of other projects are doing, where all that they do is they just like raise money from a VC fund, because when they do that, they like often end up with like 12 people having 45% of the token supply, right? So I think it's like it's easy to do a lot worse than Ethereum has done, and it's hard. Like, and I think we're lucky that like Ethereum has done worse. In terms of like what things can be further done to improve things from today, I think like manipulating the like the ETH holding supply directly is hard, but I think what is more practical is finding ways for more and different groups of people to succeed in the ecosystem, right? And the Ethereum Foundation like has a big focus, I think, on like helping people like find ways to grow and succeed, even if they like don't have access to the best VC firms, people from like very geographically distributed regions, and like people who are not kind of part of the like initial core developer and research communities, and continuing to improve those programs and continuing to just like make it easier for people who were not part of the kind of core elite Ethereum community to build things and like become a significant part of the ecosystem is probably the best that we can do today, and that's something that we're trying to improve.
Okay, thank you for your answering.
Try
Спасибо.
to get some question from that side. Yes.
Hi, I have a question. I'm B-Man from ABCD, and I want to ask some questions about the security of a ZK circuit. Because we can see that there are a lot of ZK projects launching their mainnet, like Scroll and ZK Sync, etc. But we find it really hard to audit ZK circuit, and I think that it's a really important issue, because I saw your Twitter once because you wrote about ZK security. What do you think about the coming launch of the mainnet, and how do we deal with the security of ZK circuit?
Yeah. I think, I mean, for ZK EVMs, I think what the best thing in the short term is what I call multi-provers, right? Basically, instead of relying on one proof system, you rely on at least 2 proof systems. And then if we want, you can have a governance mechanism where basically if the proof systems disagree, then the governance can decide which one of the 2 to accept as the correct one. And if you do that, then like basically that makes you much more secure against the possibility that like one of the systems has a bug, right? Because like the 2 of them, it's very unlikely that 2 proof systems will have a bug that causes them to disagree in the exact, or that causes them to give the wrong answer in the exact same way, right? So that's I think the best thing in the short term, and I know that some of the rollups are already going in this direction. Like I know Optimism already has a multi-prover system in its roadmap. I believe Linnea, I mean, they at least told me something about going in a similar direction. I believe actually ZK Sync, their next version, is going in that direction. So that's short to medium term. In the longer term, I think there is also an option of like trying to enshrine ZK EVM verification into the protocol. And that's obviously a much more complicated challenge, but like if we do that, then that would reduce the number of lines of code that people have to write themselves, and it would like put more things into kind of under the protocol. So that would improve things more, I think, in the long term, but like we're obviously not quite there yet.
Thank you.
Maybe, no. Yes, yeah.
You just
you're
missed.
up.
Okay.
Yeah. Thank you. Nice to meet you. Vitalik, I'm so excited to meet you in face to face. And I have a question. I have seen from the news that what do you think is the problem of the Ethereum staking ecosystem, or LSD? And I have known there's a platform Reflexer. You have introduced it, and how can it solve the problem of?
Good question. Yeah, I think there is like a short-term problem and a long-term problem here, right? Like the short-term problem is that like liquid staking tokens basically create this centralization risk because like if one liquid staking platform gets too large, then like it starts gaining a lot of abilities to like interfere with the Ethereum chain in different ways. So in the short term, I think the best that we can do is encourage people, like more of a diversity of these projects to exist. Right, so like one of the ideas that I had is for like Rai, which is an Ethereum-based stablecoin, to use like basically like smaller liquid staking tokens, so things other than Lido, with the goal of like trying to distribute staking more between different projects. So that's something that. So basically, like in the short term, I think one of the things that we'll have to do is just try to do everything that we can to have like a balance between some of these projects. But I think the long-term problem is like really understanding what is a stable equilibrium for staking that continues to be decentralized. And one of the big challenges there is basically that solo staking is hard, right? Like most people don't solo stake for various reasons, like they don't have 32 ETH, or it's too technically hard to run a node. Running a node requires, like too many resources. It requires too much technical work. It's not safe enough because you can't use it with a cold wallet, right? Like all of these different reasons. And we can try to improve solo staking more. That's one path. That's one path that we can take, or we can possibly try to like look for some other model, right? So. Yeah, I think if we can try to look for some other model, then it becomes easier to put it like. Like if we find some other model, then like maybe like in the long term we can create an ecosystem that doesn't like have these centralization pressures to the same extent, right? So I definitely agree that this is like a top 3 research challenge for Ethereum going into the next 5 years. But there's a lot of people that are working on it right now.
Thank you.
Okay.
Hi there, how are you?
Good, thanks for asking.
I have a pretty tricky one here, so only answer whatever you're comfortable with, okay? Mm-hmm. So within a lot of, like official authorities, they're trying to get in this sector. Mm-hmm. They're bringing a lot of topics like regional blockchain. So where do you think this is going? And what's the, like whole picture on the whole blockchain?
Yeah, I mean, I'm bearish on the whole regional blockchain thing, and I think the reason why is because people have tried for years and they have not gotten anywhere, right? Like people have tried making, local blockchains, consortium blockchains, like public blockchains that are organized around a particular country, and all of these systems, they just always end up having a very hard time getting adoption, right? Either because they're too small to like really get a community, or because it's easy for them to attract the first 5 people, but then it's harder for them to expand beyond that because anyone coming in after that sees an ecosystem that's like already dominated by whoever the first 5 people are, right? And so for like enterprise use cases, I'm much more bullish on Validiums and layer 3s, and like basically because if you use those kinds of systems, the amount of like re-engineering that you have to do is much less, right? Like from an just enterprise IT perspective, if you're going to move your application onto a consortium blockchain, the amount of technical work is like 80% as much as the work of just moving it onto Ethereum, right? Now, the cost is lower, but the amount of like initial technical work is almost the same, right? But at this, so it's like, I think making like custom enterprise blockchains or regional blockchains or any of those things, like to me, it's like you only get, you know, like 20% of the cost savings, and only 20% of the benefit of decentralization. But if you make something, like if you take this other approach of making a Validium, what you're basically telling the enterprise IT people is, you can keep your server running the same code as it is today, but we're going to add an extra daemon that can talk to the database, that can make Merkle roots hashes of the database, that can make zero-knowledge proofs of the code that you're running to update the database, and then publish those hashes and publish those proofs onto Ethereum, right? So they're not changing existing code. You're just adding new code that sits beside existing code that they already have. And I think this actually gives like at least 50% of what people want out of decentralization if these hashes and proofs go on something like Ethereum, like a public blockchain. But like instead of being 80% of the like work in re-engineering, it becomes like maybe 20% of the work in re-engineering, right? So like this is why I believe that kind of approach is like actually better and more likely to succeed. And like the reason why it hasn't succeeded yet is because the technology has basically not existed in a good enough form until like literally 1 year ago. So I'm optimistic we'll see more of those in many spaces in the next 5 years.
Thank you.
We have published some of, maybe you can.
Thanks, Vitalik. And actually, I might propose some questions about like AI. You know, that people are very curious about how AI and Web3 can collaborate together. But like AI is more about like this productivity, or Web3 is more about like these production relationships. And you mentioned that we have to focus more on these actual usages. And in terms of like these labor markets, especially like these freelancer markets, like we see this AI, the collaboration between human and AI will revolutionize how we organize these structures of these labor markets. And like these products like WorldCoin serves as some components of how we can revolutionize this labor market, the future type of it. So how do you see the chances and what other things that these blockchain technologies can foster the positive changes of this labor market? Thank you.
Yeah, I mean, I think the biggest practical positive change that blockchains can do to the labor market is just making the international economy lower friction, right? Like this is something that they do already, right? Like there's a lot of like, for example, NFT artists in Africa or just like remote workers in like Southeast Asia or India that like make money like basically by working for Western companies, and crypto makes it much easier for that money to actually flow, right? And I think like in the future we'll have like not just cryptocurrency to make the money flow more easily. We might have like ZK verification tools to make the to make it easier to identify like people like who has a better reputation. So I think we'll see like smart contracts will like make it easier to do many kinds of international business more securely. So I think like giving people in countries that are not well connected to the global system more of the same kinds of opportunities that people in existing rich countries have is probably the biggest value add that blockchains could have there.
Thanks so much.
Yeah. Probably have the last question maybe.
Someone in the back.
Oh, someone in the back. Okay.
Okay.
Thank you. Hi. I'm so nervous. Hi, my name is Coco Vitalik. I do a blockchain system for several years, and we met in China before. Very glad to see you again. I have questions about the DeFi you mentioned before, because I know DeFi always seems like some problems nowadays. What will be the future of DeFi looks like, and what are the plans for Ethereum system about DeFi system? Thank you.
Yeah, good question. I mean, I think to me, the DeFi projects that will survive in 5 years, I think are going to be the DeFi projects that are designed to survive for a long time, right? Which is very different from the projects that are designed to grow quickly, right? Like I think in the 2021 bubble, we saw primarily projects that are designed to grow quickly, and they did grow quickly, but then half of them ended up blowing up. And look, the things that will survive for 5 years are the things that are like actually good at not blowing up, right? So I think the only way that DeFi can succeed is by like having a greater focus on just stability and making, like not caring about like 3% returns versus 6% returns, but making sure people do not get minus 100% returns. And aside from that, I think it's like the best thing that we'll see is just continuing to make it easier for people to trade between assets, having exposure to different kinds of assets, like not just currencies, but also like stocks and real estate and other kinds of indices and investments. Also kind of more novel applications, including things like prediction markets, and basically just like doubling down on like tools that we already have and that already work well, and continuing to make them more usable and make them work better.
Okay, thank you so much.
Thank you for Ms. Vitalik's wonderful Q&A. And why not we give a big round of applause for Mr. Vitalik again for his wonderful speech and Q&A. Yeah. And let Professor Wen to give the token appreciation to Mr. Vitalik. Thank you.
Because Vitalik has something else to do after this, so he'll be a step away. So I hope everyone continues to stay for the rest of the conference. We have 2 sessions after this one, and also have a tea break in between. And so I'll pass the floor to our host. Thanks.